guys, welcome back on the series of packaging. This is part 2. We're going to continue from where we started. Now we're looking at consumer package content. Several aspects of consumer package labeling are subject to regulation. One of the most important is to accurately state the quantity, that is weight, volume, count of the package content. Consumers expect that the label accurately reflects the actual content. Manufacturers and packagers must have effective quality assurance procedures and accurate equipment. Even so, there is inherent variability in all processes. Regulations attempt to handle both sides of this. In the US, the Fair Packaging and Labeling Act provides requirements for many types of products. Also, the NIST has Handbook 133, checking the net content of packaged goods. This is a procedural guide for compliance testing of net content and is referenced by several regulatory agencies. Other regions and countries have their own regulatory requirements. For example, the UK has its weight and measures packaged goods regulations, as well as several other regulations. In the EEA, products with hazardous formats need to have a UFI. Shipping container labeling. Technologies related to shipping containers are identification codes, barcodes, and electronic data interchange. These three core technologies serve to enable the business function in the process of shipping containers throughout the distribution channel. Each has an essential function. Identification code either relates product information or serve as key to other data. Barcodes allow for the automated input of identification code and other data, and EDI moves data between trading partners within the distribution channel. Elements of these core technologies include UPC and EAC item identification code, the SCC14, UPC shipping container code, the SSCC18, serial shipping container code, interleave 2 of 5, and UCC or EAN128, newly designated GS1-128 barcode symbologies, and ASC X12 and UN EDIFAT standards. Small parcel carriers often have their own formats. For example, United Parcel Service has a Maxi code 2D code for parcel tracking. RFID labels for shipping containers are also increasingly used. A Walmart division, Sam's Club, has also moved in this direction and is putting pressure on its suppliers to comply. Shipments of hazardous materials or dangerous goods have special information and symbols, label, placard, etc. as required by UN, country and specific carrier requirements. On transport package, standard symbols are also used to communicate handling needs. Some are defined in the ASTM D5445, standard practice for pictorial marking for handling of goods, pictorial marking for handling of goods, and GHS hazard pictograms. Package development considerations. Package design and development are often thought of as an integral part of the new product development process. Alternatively, The development of a package can be a separate process but must be linked closely with the product to be packaged. Package design starts with the identification of all the requirements: structural design, marketing, shelf life, quality assurance, logistics, legal, regulatory, graphic design, end use, environmental, etc. The design criteria performance specified by package testing. Completion time target, resources and cost constraints needs to be established and agreed upon. Package design processes often employ rapid prototyping, computer-aided design, computer-aided manufacturing and document automation. An example of how package design is affected by other factors is its relationship to logistics. When the distribution system includes individual shipments by a small parcel carrier, the sorting, handling and mixed stacking makes severe demands on the strength and protective ability of the transport package. If the logistics system consists of uniform palletized unit load, the structural design of the package can be designed to meet those specific needs, such as vertical stacking for a longer time frame. A package designed for one mode of shipment will not be suited. With some types of products, the design processes involve detailed regulatory requirements for the packaging. For example, any package component that may contain food are designated food contact materials. Toxicologists and food scientists need to verify that such packaging materials are allowed by applicable regulations. Packaging engineers need to verify that the completed package will keep the product safe for its intended shelf life with normal usage. Packaging processes, labeling, distribution and sale need to be validated to assure that they comply with the regulations that have the well-being of the consumer in mind. Sometimes the objective of package development seem contradictory. For example, regulations for an over-the-counter drug might require the package to be tamper-evident and child-resistant. This intentionally makes the package difficult to open. The intended consumer, however, might be disabled to immediately open the package. Meeting all goals is a challenge. Package design may take place within a company or with various degrees of external packaging engineering. Independent contractors, consultants, vendor evaluation, independent laboratory, contract packagers, total outsourcing, etc. Some sort of formal project planning and project management methodology is required for all but the simplest package and development program. An effective quality management system and verification and validation protocol are mandatory for some types of packaging and recommended for all. Environmental consideration. Package development involves consideration of sustainability, environmental responsibility, and applicable environmental and recycling regulations. It may involve a life cycle assessment which considers the material and energy inputs and outputs to the packaged product, the packaging process, the logistics system, waste management, etc. It is necessary to know the relevant regulatory requirements for points of manufacture, sale, and use. The traditional 3 R's of reuse, reduce, recycle are part of waste hierarchy, which may be considered in product and package development. Prevention. Waste prevention is a primary goal. Packaging should be used only where needed. Proper packaging can also prevent waste. Packaging plays an important part in preventing loss of damage to the packaged product. Usually, the energy content and material usage of the product being packaged are much greater than that of the package. A vital function of the package is to protect the product for its intended use. If the product is damaged or degraded, its entire energy or material content may be lost. Maximization. Eliminate over-packaging. The mass and volume of packaging per unit of content can be measured and used as a criteria for minimizing the package in the design process. Usually, reduced packaging also help minimize costs. Packaging engineers continue to work towards reduced packaging. Reusable packaging is encouraged. Returnable packaging has long been useful and economically viable for closed-loop logistics systems. Inspection, cleaning, repair, and recovery are often needed. Some manufacturers reuse the packaging of the incoming part of a product, either as packaging for the outgoing product or as part of the product itself. Recycling. Recycling is the process of material pre- and post-consumer into new product. Emphasis is focused on recycling the largest primary component of a package: steel, aluminum, paper, plastic, etc. Some components can be chosen which are not difficult to separate and do not contaminate recycling operation. Packages can sometimes be designed to separate components to better facilitate recycling. Energy recovery. Waste to energy and refuse derived fuel in approved facilities make use of the heat available from incinerating the packaging components. Disposal. Incineration and placement in the sanitary landfill are undertaken for some material. Certain US states regulate packages for toxic content which have the potential to contaminate. Emissions and ash from incineration and leachate from landfill. Packaging should not be littered. Development of sustainable packaging is an area of considerable interest to standard organizations, government, consumers, packagers, and retailers. Sustainability is the fastest growing driver for packaging development, particularly for packaging manufacturers. They work with the world's leading brands as their CSR, that is corporate social responsibility, targets often exceed those of the EU directives. So guys, this is part 2 on the series of packaging. So I hope you all have been listening to part 1 series and now part 2. Now we're going to continue from packaging machinery as part 3. So do well, stay tuned. So there's going to be part 3 and the final part on the series of packaging. Do well, stay tuned. Bye.